Here we have an example of the law of squares. If you have everything in order, as we are used to, add up all of this row, add up all this row, add this row and this row, you get different numbers. So how can we arrange each of these numbers without repeating the number and have them all equal the same sum? This is what some people refer to as I Ching math, or Low Shoes magic squares, or John Searl's law of squares. And there's another man on YouTube, Lee Burton, who has unbelievable diagrams incorporating Marco Rodin's math, John Searl's math, Low Shoe, the I Ching, and again you can find that information in the video description. Here we have some of the neodymium cores for the rollers. Four materials. Innermost is raw, unmagnetized neodymium. Second layer, the white, is Teflon. The third layer is the magnetic, ferrite. And the fourth is the copper. Only the third layer is magnetized. The neodymium core is not magnetized. Some people argue that Professor Searl could not have built his SEG back in 1946 because neodymium magnets weren't into production until 1982. But Professor Searl never used neodymium magnets. He used ferrite and raw unmagnetized neodymium, which he got from China. Professor Searl was able to build a lot of these devices back then because he had access to all of this type of equipment for free when he worked for British Rewind Electric Company. They provided him with all of these materials, all the workers necessary, and everything needed to complete the project for free. The only thing that he paid for back then was the raw neodymium powder at 39 pence a kilo. And all of the machines that Professor Searl was able to use for free back in the day, we now have to purchase ourselves at modern day prices with more modern units.
Here's an example of what happens if you don't get your materials and figures right. And here's one of ours. You can see quite an improvement.
And that's all oxidation from the neodymium?
Right. Our material holds up far better. Like, these are 4 years old. It should have turned to dust by now.
They're not coated with anything? That's just...
No, it's just bare. And this is proprietary to our research. This allows us to work with the material in normal atmospheres and not in an argon chamber. And once the SEG is up and working, oxidation is completely prevented because there's an excess of electrons preventing the chemical reactions it makes for oxidation.
A lot of people have asked what these dots are. These are just to place the ring evenly in the center. They have no function whatsoever. They're just plastic dots for centering. But also people have a question regarding the third layer on this unit. We see this one has sections.
That is a complete layer.
Now, does the unit have just one solid ring, or does it have sections of it?
Ideally, it would be nice if you could find a manufacturer who would make it in one. complete ring.
And what are the
But
problems with making the
well-
complete ring?
Well, they just can't manufacture anything that big. So we have to segment them. But still, it works for our purposes. In fact, we'll have to use sections for the even larger ones. And if it's magnetized correctly, it's not a problem. So effectively, that's what we're doing right here. We're rotating the segment,
That's one of the rollers, the
the magnetic layer.
uniquely magnetized.
You can actually see some variations on the compass, an indication that this is not a standard magnet. If it was a standard magnet, it would be uniform and there would be no movement of the needles. As an electrical engineer, we know that rotation is this way. That's one vector. 90 degrees to that is the magnetic. That makes sense. Therefore, the electric has to be this way. That's the theory operation of the SEG. And we can see the motor ability of it concurs. But if currents are going through the roller, what happens? Well, as far as I can tell, that would explain why the rollers move. If you got currents going through a roller, the magnetic effects are such that you should get rotation. It's just the inventor has always said. Now, if we can demonstrate that, it will be another proof of concept.
Now, what we have here, this is the SEG mock-up. I got to say that again for all the YouTube people and everybody wanting to know more about this stuff. This is the demonstration unit mock-up. There's a difference between the SEG mock-up and the SEG prototype. This is being powered so that the electricity goes through the wires and makes the magnets spin in this unit. That is to display the motor ability, spin forces, basic magnetic interactions.
Right, it is a platform for experimentation and testing, improving the various facets of the technology. And this is the way we're doing it. In reality, we have to deal with the particular aspects of the technology, prove it, move on to the next, so forth and so forth, until we get to the point where we can develop and put together a prototype which looks like that. And even that's not complete yet because there's a sophisticated process called magnetization. Unconventional. The industry does not practice. We have to make our own equipment, our own processes in accordance to what we know about the SEG technology. And all this takes time, money, and effort, which everybody would appreciate. That's what Searl Magnetics is here for.
So when this is in operation, it is not producing any usable output. It is just spinning the magnets.
It allows us to isolate and demonstrate the various functions of the SEG, and it prove the concept, but it is not a full prototype. We're working on that. It's a regular magnet. If you just roll it, it's nice and uniform. But if you made an impression, you can immediately tell there's something different about it.
It jumps a little bit.
Yeah, that's got a wobble to it, a magnetic wobble to it. So that immediately tells you that something unusual has happened. This is not a standard magnet.
Wow.
First magnetizer that I made from scratch that proved that you can impress waveforms upon permanent magnetic materials. And well, this is the setup that is required. This is one of the magnetizing coils. You see it's nicely uniform. You should get north-south, but you don't. You get variations, which again proves another facet of the SEG concept is that you can magnetize magnetic materials uniquely. So we're putting all these facets together, and all the work that I've done has confirmed Professor John Searl's claims. So anybody that is quick to say negative things, they need to really think about what they're saying. Ask yourself, are you an expert in the subject? Or are we the ones who are actually doing the work? Go ahead and put this near the surface of the copper ring. Remember, this data ring, just like the market, we're isolating another effect through the SEG concept. Get closer, closer, closer. Now you feel repulsion force? That's the magnetic bearing. Furthermore, it is rotating without touching it. Just the way John has always described it, that it will orbit and spin. Therefore, the SEG will never wear out.
Computers to help regulate the signals during the magnetization process. One of the 6,000-pound magnetizers. And the brand new CNC lathe.
Demonstrate control. It's all logical controls here. You just panel. For example, we can go ahead and run the chuck. Speed it up.
This thing came from China.
The SEG mockup, we can find another explanation for another function in the SEG, and that is, why do the rollers move? Now we know that the electrical vector is this way, therefore currents generated between the magnetic layers and the other materials. In effect, the layers are what is the generator, and we know the electric fields are this way. Therefore, what we're going to do is simulate the electrical currents as we know the SEG. The magnetic forces through the rollers should make the rollers move. And this is what this setup will do, is to demonstrate that effect. We'll go ahead and apply currents through that wire and see what happens. The point is, the proof of concept is there. Is that you will get rotation. And you notice, unlike a conventional motor, you don't have to flip the polarity to get rotation. It is in effect a homopolar mode. It allows you to move the direct current this way. This supports the SEG concept. It also vindicates Professor John Searl in the SEG theory of operation. Furthermore, so here at Searl Magnetics, we're in effect, anybody who is trying to debunk us, we're debunking them. And the way to do that is to proceed with progress and let the results speak for themselves.